welcome back everyone. Today we're going to look at an application of the derivative. We have the cost function up here, the total cost function. The cost function, c of x, is 810 plus 0.1 x squared. So this is our cost function, our total cost function. And the question of the day is to find the minimum average cost. So how does one find the minimum average cost? This is important. You can't go too blindly too fast. Where I see people always have the problem is they just go, ooh, minimums. Dr. McCullum said derivative equal to 0, blah, 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 blah. True, but you're not reading. That's the cost function. This is the minimum average cost. So you need the average cost function. The average cost function has a symbol. It's called C bar. Not sure who made it up. Looks good to me. The average cost function is C bar. Well, average cost, that's cost per unit. There's the cost function. I'm just going to divide it by unit. And the typical letter for unit is X. Cost per unit is average cost. So you get the cost function. The average cost is cost per unit. So that's the function I want to minimize. I need to make that very clear. This is the function I'm minimizing. Please be careful when you do this. Allow me to rewrite this. I'm going to do some good old-fashioned algebra. Now, yes, it is a fraction. If you want to use the quotient rule here just to check your skills on the quotient rule, go ahead. I'm an algebra kind of guy. I know that in a plus, I can split this into two problems. I could split this, sorry guys, as 810 x to the minus 1, because it is really 810 over x. 810 over x, the x comes up as a minus 1. Again, at the plus, split it. 810 over x is 810 x to the minus 1. That x gets distributed to both of them. Add a plus, good algebra, that x goes into both of them. When that x goes into there, that's a 0.1x. So there's my function when I simplify it according to algebra. No derivative. Now comes the derivative. The reason why I did algebra first is because the derivative of this is nice, simple. The quotient rule is simple too. All right, you get a nice, simple thing you can, conclude. What's the word I'm looking for? Simplify. I'm just avoiding the quotient rule. The derivative of this is negative 810, because you bring the negative down. Subtract 1 from the exponent. The derivative of 0.1x is 0.1. Don't forget the 0.1. I can see the decimal messing with people, so be careful, guys. So that's the derivative. I'm going to rewrite the average cost derivative as negative 810 over x squared plus 0.1. So if the question was to find the derivative of the average cost, there you go. Could be part A, right? Part A of the question. Find the derivative of the average cost. Heck, part A could be find the average cost. Again, we're trying to find the minimum of the average cost. Take cost divided by units, you get average cost by definition. The derivative of the average cost is right there. Why do I care about the derivative? If you looked at my other videos, where do you find mins and maxes? The derivative equal to 0. And that's what I'm going to do. So it's algebra time. Honestly, that's all calculus is just utilizing the algebra skills you have from high school or sharpening them up. So how do I solve that? What I got to do, subtract off the 0.1. Subtract off the 0.1. Divided by x squared, to get rid of a division, you multiply both sides by x squared. Or, better yet, put this over 1, cross multiply. So what I get here is negative 810 equals negative 0.1 x squared. Got to solve for x squared, so I'm going to divide that back over. So I'm going to divide negative 810 by negative 0.1. A negative 810 divided by negative 0.1 is 810 divided by 0.1. Now 810 divided by 0.1, and that equals x squared. You can take your calculator if you need to, or you can just slide the decimal. 810 divided by 0.1 is 8,100. So I have the equation, and I am running out of board space, so I need to continue on here, is I need to solve this thing. All right, so I have 8 squared, x squared equals 8,100 is what I have right now. So I can sneak it up here. never like doing this. X squared equals 8100. I would love to know what x is that, right? X squared is 8100. What x has the ability of multiplied by itself to make 8100? Obviously, Dr. McCullum made up this example. It's 90. 90 times 90 is 8100. Now, yes, I understand it is plus or minus. I agree. Don't slap me here, professors. Right? There is a plus or minus. Understand we're doing cost. Cost, x for negative, x doesn't make sense. Negative units doesn't make sense. That's why I'm skipping that. But to be honest, you're right. When you square root, you get a plus or minus 90. I'm throwing one of them away. The only value that's of interest to me is 90. So 90 is probably the minimum average cost. Now, again, and I'm not done yet. I want to really nail this home because I want to follow just like every video I've done with you. I take the function, algebra if needed. I take the derivative, set equal to 0, and solve. Always. Derivative, set equal to 0, and solve. I agree. A minimum. Derivative, set equal to 0, and solve. There is one other thing I want you to do. Build me my first derivative test to guarantee that's the minimum. How do you know that's not a maximum? How do you know? You don't know yet. There's nothing on this board that says min or max yet for what that is. So we need to analyze that. So, here we go. Erase this beautiful work. Making me to tears here. All that beautiful algebra erased. I'm going to put 0 on here, and I'm going to put 90 on here. I'm going to break my universe up at 0 and 90. Now you might be saying, whoa, why 0? Well, let's pause. Never go too fast or too furious. All right. The reason why I got to be careful with 0 is let's look at the derivative. Where there's one value that the derivative does not like, and you should always keep an eye on those. When x is 0, you get a 0 in the denominator. The average cost, well, really doesn't make any sense when it's 0, right? What is the average cost if you produce nothing? What is the average cost if you buy nothing? Doesn't make any sense. You're dividing by 0. Average cost means nothing when you buy nothing. So that's why the derivative has an issue there. That's why I'm looking at it. Honestly, we just discussed, I don't care about anything prior to 0, to be honest. Those are negative units, right? X would not be negative here. We're doing cost function for production. Why would you produce negative 2 units? You wouldn't. At least not that I'm thinking about. So really, all I care about is getting back to my work here, picking a number between 0 and 90, like 10, and a past number like 130. I don't care which numbers you pick. I wanted you to be careful, though, because you could have picked 0 and go, whoa, if I plug 0 into the derivative, I'm screwed. And you're right, you are. At 0, average cost is not defined, so the derivative is not defined. So I am careful of that, because what I always teach you guys, plug into the derivative and let's see what happens. Let's plug into the derivative 10. When we plug in 10, we get 100. We get negative 810 over 100. So that's, what is that? Negative 8.1 plus 0.1. That is clearly a negative. So I know my function is decreasing from 0 to 90, because that's what it means. Derivative is negative. Again, plug 10 into here, take your calculator out, plug 10 into x, and see you get a negative value. A negative derivative means slopes are negative, means you're decreasing. Go back to previous videos of max and mins over and over until it gets into your head about this. We're in the application section now. So I hope you looked at previous videos about max and mins, just over and over. All right. 130. Plug in 130. When you do, you're going to get a positive. The reason being is 130 squared makes this fraction below a 0.1, and so you get a positive value out. And if you don't trust me, plug in 2 billion, because I don't care what you plug in. Any number past 90. Plug in 2 billion. 2 billion squared is huge. Negative 810 over huge is close to 0. Plus 0.1 is positive. So I definitely know my function is increasing. And if I go from decreasing to increasing, I have definitely found my minimum. So at 90 units, I have got my minimum average cost. At 90 units, please answer your question carefully. If it wants the units, it's 90 units. If it wants the average cost, and I guess that's what I'm looking for here, huh? Average cost. I'm not done yet. This is the units. This is how many units I need to produce or sell or whatever we're doing here. 90 units. is the x. You need to plug back into the function to find your average cost, right? Average cost. So I need to plug 90 back into there, and that'll give you your average cost. When you plug that back into here, you'll get your actual average cost. That's minimum. 90 units is what you should buy. The cost per unit you're about to find. When you plug 90 into there, you'll get your cost per unit. That is your best average cost in this situation, because it'll be the minimum average cost in this situation. Thank you guys for watching this video. I hope you've enjoyed it.